Help me with number 1. The value of x, find the value of x, and find the length of each chord. What should I do?
6 times 8.
6 times 5 equals 8 times x. Okay. So 30 equals 8x, therefore x equals, what, 3.75? Okay, is that my answer?
No, you have to find each one.
I got to find each one. So I saw somebody put down that AB was 30. What are they thinking? They're multiplying, but what should they be doing? Very good. It should be 11 then. Okay, and then CD is how long?
7.5.
CD is 7.5? Oh, 11.75. Okay. Had a small hiccup there. We got it though. So the chord product theorem, easiest theorem, yeah? My worry is that you're going to use that theorem in place of the secant-secant product theorem and confuse them. So let's jump over and look at the secant-secant product theorem problem, see how we do there. It says find the value of z and the length of each secant segment. What's my equation going to be?
9.
Go ahead.
9.
9 times?
9 times 30.
Not 9 times 30, careful.
9 plus 30. Oh, 30.
9 times 39. You have to add. Remember, it's the entire secant that goes inside.
Yeah.
Equals 13 times z plus 13. Can you see that you were confusing the chord product theorem? You were just multiplying segments. It's an easy trap to fall into, my young friends. Be very careful there. You could put 9 plus 30 in there. That would have been fine. I just condensed it down to 39.
But then I multiply each.
You could do that. It still works out. So Christina's asking if I could just put 30 plus 9 in here and then distribute the 9 to each term. And the answer is yes, you could do that. It would totally work. This just seemed the faster route, just to add them directly. But both methods work. Now, gang, how do you want me to solve this problem? There's 2 ways to solve it. You can distribute the 13 and then multiply the 9 through, and then you can solve that way. There's also a faster way. Do you want to see the faster way? Or do you want to see the more intuitive way?
More intuitive way.
Intuitive way it is. So we're going to multiply 9 times 39. Let's see here. 9 times 39. We can do this in our heads. 9 times 39 is like 9 times 40. 9 times 40 is what, 360? But that's 1 9 too many, right? So I got to take 9 off of that. So 351. It's 360 minus 9, basically. Right? Because I only need 39 of them. I don't need 40 of them. And on the other side, we get 13 times z plus 169. Make sure you distribute the 13 to both terms. Let's see. Subtract the 169.
Yes. 180.
Okay, 182.
And then equals 137. 13z.
And then divide both sides by 13, and you get 14. So there's what z equals. We need to do what now? Yes, so we need JG first, or GJ. Could you give me that? What's GJ? Okay, I'm hearing 27. Can anybody confirm?
Yes.
Okay, and of course we already know LG. What's LG? Or a 2-year contract, right? Of course. Very good. Now, can I show you the faster way too while we're here? So this is just a nice math trick, and it's not hard. It doesn't. You can't use it every single time, but when it's available, definitely use it. It saves you a little bit of time, and it makes you feel like you're smart because, well, you are. Can you see that this side I could divide 13 out, get rid of that 13?
Yeah.
On the other side, is anything here divisible by 13? Well, the 9 isn't, obviously. What about 39? Yes, because 39 is 13 times 3. So I could divide both sides by 13. It actually makes the job a little bit faster. So divide this side by 13, divide this side by 13. So the 13 there crosses out. It divides 1 to 1. And we get z plus 13 on the right. And on the left, 13 divides into 39 3 times. 9 times 3 is. And so now I subtract the 13 and I get z is. Same answer. Just a little bit faster, right? So it's a nice math trick. If you can do it, great. If you can't, hey, then don't worry about it. But if you can use it, right? It's a method of opportunity. If you have the opportunity, use it. All right, let's see. How about this one? Let's go with Angelica. Can you help me set this one up?
times 7 plus what?
Okay. Thank you. Keep going.
Equals 10.
Equals 10. What do you guys think?
Squared.
Oh, wait.
We got to multiply this times itself. The tangent times itself. Yeah. So 10 squared. All right. So we got 49 plus 7y equals 100. So 7y equals, what is that, 51?
Yeah.
And then we got to divide both sides by 7, which gives me 7 and 2/7, which is approximately 7.2829, somewhere in there.
7.2857.42.
There we go. Well, of course, I like it exact. So I like mine exact, so I read it this way. Okay, are we okay with this, folks? Excellent. So this is the end of the first section.